Now it's time to do the test for the significance of the entire equation. That test is called the F test. F is another probability distribution. Alright, so this is the F test for the significance of the regression. That is the whole equation. And at first we need to give you some background on this distribution. The shape of the distribution, I will draw it as representation, or represent it much like I would do the chi-squared. So this is an F with certain degrees of freedom. The F test that we'll do will always have the alpha in the upper tail, and the test is such that if you get below that, whatever you're testing in the null is insignificant, and whatever you're testing in the alternate is significant. Alright, remember I told you a little while ago that any estimated variance, say some concept called variance 1, is some appropriate sum of squares divided by its respective degrees of freedom. Well, it turns out that the F calc is the ratio between two estimated variances, say variance 1 and variance 2. Well, if any variance is a sum of squares divided by degrees of freedom, then clearly we have sum of squares 1 divided by degrees of freedom 1 on the top, and say on the bottom, generically, sum of squares 2 divided by degrees of freedom 2. The point being here is that we'll have 2 degrees of freedom here, one for the top line of the F calculation, one for the bottom line of the F calculation. Okay, so over here we'll have 2 degrees of freedom to be concerned with. Alright, let's look at the typical, what is called ANOVA table that appears in regression output these days. ANOVA stands for Analysis of Variance. This helps us with the information we need to do the test, but it also gives us, some of us anyway, a better understanding of what the regression is trying to do. So let's create a table here. First column we'll talk about the source of the variation. Alright, and that's our first sort of stop, and that is we want to explain the total variation in the y variable. Okay, so at the bottom here is the total variation. We're trying to explain the variation in the y, not really the level. We care about the variation. Why does the variable y move? And we use the regression to help explain. And what the regression doesn't explain is attributed to the error term. Alright, so for notation, the sum of squares, which is explained by the regression, is SSR. Sum of squares due to the error term is SSE, which we've seen before. in simple regression, and the sum of squares for the y variable for the total is SST. And we've seen this item before in simple regression and called it SYY, the total variation in the y variable. Alright, every sum of squares needs an associated degrees of freedom to calculate some variance. The sum of squares, the degrees of freedom associated with the regression sum of squares is k. Degrees of freedom associated with the error sum of squares n minus k, and these concepts are additive in both these columns, and so the degrees of freedom associated with the y variable, as it always is, like an x variable also, is n minus 1. Alright, so as I said, these concepts are additive, so that the total sum of squares is equal to the regression sum of squares plus the error sum of squares. And these sum of squares must be given to us. Alright, with any two of these three sum of squares we could work out the third one. Degrees of freedom we could work out. We know what k is, the number of x variables. N minus k can be worked out. N can be worked out given n and k. Alright, so let's now go to our Excel output and look at the ANOVA, or analysis of variance table. Alright, you'll see that they've called it regression, which we did, and they've called it residual, where we call it the error sum of squares, and then they have the total sum of squares. They put their degrees of freedom column first, but in the following column is the sum of squares. Okay, so the regression sum of squares is 1.0653. The sum of squares for the error is 0.13524, and the total is 1.19155. Okay, so what we'll do is we'll write down just the first two of these and go back to our problem and do the work. Okay, and do this test from scratch. Alright, but first let's point out what the F-calc will be. The F-calc will be the regression sum of squares divided by its degrees of freedom. Divide that by the error sum of squares divided by its degrees of freedom, n minus k minus 1. Okay, and so for this problem, the regression sum of squares is 1.05632 rounded off sum, and the error sum of squares is 0.13524. Okay.